Okay, so today is the G12. G12 called as a two portion. Electrical system. I have already finished the electrical system for power. Now the electrical system for the electronics. So the electronics we have the three major portions. The power supply I finished, and also there's a analog electronics, and now I doing the digital electronics. So analog electronics I introduce the amplifier. So amplifier function is a amplifier utilized to amplify the signal. So amplify the signal can be the this is for the amplifier. So we have to put the input signal. So input signal is amplified. So input signal, and you have to supply the input signal, and then you also connect it to the power source. So amplifier input signal amplified. So this is output signal. So input signal amplified by the amplifier by the output signal. So output signal will be the greater than the input signal. So this amplifier we supply the power source. Power source needs to be supplied so that the equipment in the amplifier can work. So the input signal amplified and the output signal will be produced. So this is for the general power of the amplifier. This is for the amplification drive. So the input signal amplified by amplifier. So this is the way the amplifier will be working. So the amplifier we can utilize for the transducer. Transducer can be the input for the voltage to the current transducer, or the motion to the voltage transducer, or the compression to the voltage transducer. Those transducers are being utilized in the various electrical installation and the application. So the transducer usually produce a small signal. So this small signal need to be enlarged. So by this way we utilize the amplifier. Amplifier enlarge the small input signal to bigger output signal. So we can draw the equivalent circuit of the voltage amplifier. So amplifier needs the input signal source, and also this signal source is amplified and output with the larger signal. So that's the amplifier circuit. You can draw the equivalent circuit. Equivalent circuit of amplifier. So those units are running in line with the electronics unit. Power supply is H011. Electronic code that is run like this. Analog electronic is this is for the amplifier. The H013. Digital electronic is H012. So those units are running in line with the those units. So you can got the advantage because when you finish the G12, E29 with the my program, and later when you need apply, you can apply the RPF for the those units. So equivalent circuit of the amplifier, we can get the equivalent circuit. So input signal source is this one. So this is for the input signal source. So this is the RS and the VS. So this will be the input signal source. So then this is the amplifier we supply with our input resistance. So this is the signal coming here. So this will be the input signal VA multiplied AV multiplied VN. AV means that the voltage gain, and that will be the R out. Output resistor. So then we can draw the equivalent circuit for this amplifier source. So then we use R low. So the whole thing we can draw in the amplifier. So this is for the amplifier equivalent circuit. So this is the R in means the input resistance. So okay, so this is the input is the source voltage. RS means the source resistance. So RA means the input resistance. So AV means the voltage gain. So VA means the input voltage. So RO means the output resistance. So load means the R load means the load resistance. So those are the equivalent circuit for the amplifier. So this is a body amplifier. So this is the equivalent circuit for body amplifier. So body amplifier we can also calculate voltage gain. AV can be calculated. So V out divided by V in. And similarly AI current gain. Current gain in I can be calculated. I out divided by I in. So this current will be the I out, the current will be the I in. Also power gain AP. So P out divided by P in. So AI means that current gain. AP means the power gain. So input, output resistance, and that's we can calculate the AB, AI, and AB by this way. So therefore, the input resistance you can also calculate V divided by I in. That will be the input resistance. So the resistance measure at the input terminal of the amplifier. That will be the input resistance of the amplifier. So the transistor can also be we can draw the construction. So there will be N layer, P layer, and the N-like layer. So there will be this is the base. So this is the emitter, and this will be the collector. So that is the equivalent to the 2 diode. So this is the C, B, and this is E. They also similar to this one in construction. So this is the B, C, and the E. So this is called this amplifier called MBN. MBN amplifier. And similarly, we can also construct this is a P layer, N layer, and P. So this is a B, E, and this is C. So that one you can also construct the equivalent circuit diagram. The 2 diode like this. So this is a base, collector, and the emitter, E. So B is a base, E is a emitter, and C collector. So that's one also similar to the diagram of construction. So this is a base, C, and the E. So those are the construction diode equivalent in the symbolic cycle of the MBN and the PNB transistor. So those are the transistors. So this first one is the construction. So second one is the diode equivalent. And that one will be the symbolic symbol. So those are the transistor, MBN and PNB transistor, the construction, diode equivalent, and the symbolic symbol. So we can put it across the BVE. When you want to make the conduction to the transistor, then you supply the voltage across the BNE. Normally, the electron cannot flow. Only the electron are normally we call this is the potential barrier. This is the potential. So electron is this is electron here. This electron cannot climb at the potential barrier because of so this potential barrier is high. So normally those transistors are semiconductor. They are not conducting at the normal saturation. This potential barrier needs to be reduced. So you have to reduce by applying the BVE. So BVE BBA is applied to reduce the potential barrier. So this is those of the electron gas are passing through. So therefore, this BBE and the current flow through the transistor carries a flow on the graph. So horizontal line will use the BBE, vertical line will use the I beta. So then with the conduction at the 20 degrees centigrade, we follow this way, and 80 degrees centigrade is followed that way. So then we use the transistors body across the BBA, we usually given the 0.64. 0.64, and then when the BBA increase, so then depending on the temperature, current flow to the base will be the gradient. So this is called as transistor equivalence diagram. So therefore, the current gain can be also calculated. The transistors this is the transistor here. So this is called this body is BBE, and here we supply another like this. So this is a base, collector, and emitter. So this current is the IB, this is the IC. So beta can be calculated IC by IB. So IC will be the collector current, and beta will be the base current. So IC will be collector current, and IB will be the base current, and the beta will be the current gain. Current gain also you can use another thing HFE. So current gain of the transistor can be calculated. Beta is equal to IC by IB. So this is for the transistor basic equation. So this beta values are different from the one transistor to another transistor. Okay, so for the transistors they are with the typical voltage. So the important one is the voltage between the VCE. So VCE will be the collector voltage. So collector voltage. So this will be this voltage VCE around 0.2 to the 0.7 volts. So this is for when you get the VCE, this is around 5 to 7 volts. So this for your transistor here. This is a B, this is a E, this is a C. VBE is around 0.6 volt for the typical transistor. So VCE is this is a VCE, around 5 to 7 volt. You have to supply. Around 5 to 7 volt, then so if the voltage is greater than the 5 to 7 volt, then you have to utilize the appropriate potential divider. So normally the transistor they set it up 5 to 7 volt. Okay, so then we can also see that package. So those transistors are usually we put in the package because the package we also include the heat sink. Normally when the electrical current flow, the transistor electronic devices can be heated up. So this heat need to be dissipated. So dissipated by the metallic cage. Metallic cage has to be utilized to dissipate the heat. In the meantime, the power rating of the transistor. Power rating is depending on the maximum current. So maximum current can be delivered from the collector. It can determine the power rating of the transistor. Okay, so this is for the power rating. So case outline in the side of the package used to contain the transistor element. Power rating means that the power rating of the transistor determines the maximum collector current that can be used for this transistor for a given collector emitter voltage. So the rating of the power rating of the transistor is dependent on the collector current. So the power rating of the transistor can be about the 300 milliwatts to the 100 watts. So power rating will start from the 300 milliwatts to 100 watts. Using the amplifier, so an IB amplifier will produce an output signal that has exactly the same shape as the input, except that it will be larger. So this means that the amplifier used to amplify the signal. Signals are input sine wave, output should be the sine wave. The waveforms should be similar, but the output will be there greater than the input. Output magnitude will be larger than the input. This is why we have utilized the amplification. So we use the amplifier in the various amplification stage. All the sound signal, electronic signal, they can be amplified by the amplifier. So transistor biasing. Transistor biasing means that you need to supply the voltage across the terminal, especially the base to emitter. Normally, this is the potential barrier. This potential barrier is high, so the electron cannot flow. So that we need to reduce this potential barrier. So only the way we can reduce the potential barrier is we supply the voltage across the base and emitter. So by supplying the voltage across the base and emitter, this potential barrier can be reduced. So the electron can flow. So the way to connect the base to emitter is the base connected to positive, emitter connected to negative. This is we call it the forward biasing. The reason to do the forward biasing is it's enabled to allow the electron to pass through. So now the forward biasing circuits are utilized to allow the amplifier to work. So that we have to utilize the various forward biasing circuits. Okay, so when you as an amplifier, a transistor needs to be forward biased. So we have to provide the forward bias voltage so the transistor, so the base of emitter junction must have the voltage across it on the 0/6 volt. So between the base and emitter, you need to supply the 0/6 volt. The voltage needs to be supplied from the DC power supply, and the various methods are used to achieve that voltage. So this is the ways we have to forward bias the transistor. Now we withdraw this without the forward biasing, so we cannot transistor cannot work. So to work as an amplifier, we have to provide the forward bias. So now I will give you the basic transistor amplifier circuit. For the transistor biasing circuit connection, so this transistor, so this is the base, collector, and the emitter. So we connect this value. So RB means the base resistor, and C means the collector resistor. IB means the base current, IC means the collector current. So VB means the base voltage, and the BC means the collector voltage. So VCC is the supply voltage. So we have to connect this circuit so that the amplifier can work as a transistor. The transistor can work as an amplifier. So this means amplifier. So this amplifier is a firstly DC connection. DC connection means that we just supply the transistor biasing circuit. We just supply the input voltage, but there no input signal is coming out. So no input signal is applied. So this is just for the basic situation. So this is a DC condition. When an amplifier has a no input signal, the DC voltage around the circuit is reversed to as a DC quotient voltage. So this is for the DC condition. So this DC condition is that we have to reduce the potential barrier. We did the biasing because we want to reduce the potential barrier so the electron can flow for the conduction. And after that, we can provide the input signal. So that situation is the biasing circuit. Biasing circuit means that we make the amplifier to work, so make the prepare itself to ready for work. After that, we can supply the input signal. Input signal will base, so this signal can be amplified. So this is the way the amplifier will be working. So this situation is a transistor biasing situation with a DC connection. We only supply the DC biasing voltage. We haven't applied any AC signal yet. Amplifier circuit given, so we have to calculate the IB. So IB is this current flow CI is the IB, and we also need to calculate the IC and also the BC. So we have to use the formula. So IB formula is VCC minus VBE divided by RE. So the VBC will be the VCC already given 20 volt. VBE is for the silicon 0/6 volt. RE means 3.9 so mega ohm. Mega ohm means that you have to utilize 10 power minus 10 power 6. So this is for 20 minus 0/6, so 19.4 divided by 3.9 into 10 power 6. So by solving this one, that will be around the 5 microampere. So this is the ID. IC can also be calculated. The formula is beta ID. IC is the beta ID. In this case, beta is already given as 200. So beta is given in this 200. So we substitute beta is 200 multiplies ID is 5 microampere. So this is at 1000 microampere or 1 milliampere. And then BC. BC formula is given as formula is VCC minus ICRC. BC got the formula. This BC is a VCC minus ICRC. So VCC is 20 volt. IC we already calculate. IC weighs at 1 milliampere. 1 into 10 power minus 3. RC value is at 10K. 10 into 10 power 3. So by solving this one, there will be 10 volt. So this is the way that we can calculate the IB, IC, and the BCC. Okay, the next one is the factors are influencing the performance of the transistor. So transistors are performing. Transistor performing is how much current IC will be produced, how much amplification. For example, you see that this equation here, IC is equal to beta into IB. So beta means that the amplification factor, current gain. This current gain beta is very much depending on the temperature. When the temperature change, beta value will also be changing. So when the temperature change and the beta value will also changing, it can affect on the IC. So the amplifier working situation is we can design the electronic circuits to get the specific condition. So when we expect there's a certain IC and ID, certain amplification factor need to be achieved so that the electronic circuit can work well. But when the temperature is higher or lower, so higher or lower temperature affect the change in the beta value. So when the beta value change, output current IC will also be changing. When there's an output current IC varying or the fluctuation, when you are using it as an amplifier or for example as a radio amplifier, your sound will not be clear. Sound will be the saturation, fluctuation, and then you can see the humming or a lot of noise can come out. Because the reason is the beta will be changing depending on the temperature. So therefore, when we are using the electronic circuit, electronic equipment, we need to keep the constant temperature. This is why we have to use the air conditioning system. So where there are many electronic circuits, we have to utilize the air conditioning system to keep the constant temperature. In the previous programs, we already know that IB is a 5 microampere. 5 microampere is IB. Then that time beta value is 200. Beta value is 200. So IB is a 5 microampere. And then IC will be at 1 milliampere. This is based on 200. Now the beta increase from the 200 to 300. So first calculation beta value we utilize at 200. Now beta is changing from the 200 to 300. So in this case we have to recalculate the BC, how much BC we need. So in this case IB is we already know IB is 5 microampere. So beta will be 300. And therefore the IC can be calculated. Beta into IB. So this is 300. So IB value we substitute 5 microampere. So there will be the value will be 1/5 milliampere. Then you can calculate the BC. BCC minus ICRC. So BCC value is unchanged 20. IC value is 1/5 into 10 power minus 3. And RC value is not changed. 10 into 10 power 3. So therefore you can calculate the BC. The new BC value will be 5 volt. So BC value will be changing. When we change the beta, BC value will be changing. So this is the way that you can see that the beta is depending on the temperature. Temperature change, beta change. So the BC will also be changing. So this is the performance of the electronic circuit is changing. The next topic will be the potential divider biasing. So this circuit is a very simple circuit. We just direct supply the BC. VC voltage is only the 5 to 7 volt. We can get the more than that voltage. If you get the more than that voltage, this transistor will be damaged. So we only need to provide this 5 to 7 volt across the VC. So when the supply voltage is more than the 5 volt, so when we are using the more than 5 volt supply voltage, we cannot directly supply the voltage to this amplifier, the transistor. So we have to use the potential divider as a resistor. Now I give you this these are the practical circuit that we use the potential divider to apply the appropriate voltage to the transistor. So this is we call the potential divider biasing. This is for the potential typical potential divider circuit. So this transistor is Q1. Q1 is here we use this is base, collector and the emitter. So supplying this at 20 volt and this is the ground point. So between the 20 volt to ground point you use the R1 and R2. R1 and R2 are the potential divider. So that by using this R1 R2, we voltage BV will be reduced from the VCC 20 volt. So depend on the potential divider. So this voltage and also we utilize the emitter resistor. So then you can see the voltage. So VC will be the voltage feed collector to ground voltage. VE will be the emitter to ground voltage. VBA will be the voltage between the emitter and the base. So VB will be this base to the ground voltage. So those voltages are depending on the value of the R1 and R2. So then we can calculate the VB. Voltage VB can be calculated by the formula. VB is equal to VCC multiply R2 divided by R1 plus R2. VE. VE can also be calculated. This is a VB minus VBE. And IE. IE equal to IC is equal to IE divided by RE. And the VC can be calculated VCC minus IC into RC. So those are the formula to be utilized. So for the potential divider biasing. If you utilize the potential divider biasing, so this is the R1 R2 the biasing resistor, VCC is to the supply voltage, VC will be the collector to ground voltage, VB will be the base to ground voltage. VE will be the emitter to ground voltage. Those voltage can be calculated by the those formula. VB is equal to VCC multiply R2 divided by R1 plus R2. VE is equal to the VB minus VBE. IE equal to IC is equal to the VE by RE. And the VC is equal to VCC minus ICRC. So those are formula to be utilized for the potential divider, the biasing problem. It's this circuit. So this is this circuit with the supply voltage. Supply voltage is already given as 20 volt. So RC value, RE value, R1, R2 values are given. So we have to calculate the VB, VE, IE, and the VCC. Okay, so we just use the formula. VB can be calculated, so that's with the VCC into R2 divided by R1 plus R2. The VCC is at 20 volt. R2 is at 22 KO. R1 plus R2 will be the 220 plus 22 K. By solving this one, that will be the 1/8 volt. And also the VE. So VE can be calculated VB minus VBE. So VB minus VBE, so VB will be the 1/8 volt, VBE is 0.6. So that will be the 1/2 volt. And the IE equal to IC. So IE equal to IC can be calculated. The formula is the VE divided by RE. So VE by RE, so VE will be the 1/2. RE will be the 1 kilo ohm. So that will be the 1/2 milliampere. And VCC, VC, the formula will be the VCC minus IC into RC. So the VCC will be the 20 volt. IC is we already know the IC is 1/2 into 10 power minus 3 ampere. And RC will be the 10 kilo ohm, 10 into 10 power 3 ohm. So by solving this one, VCC will be the 8 volt. So this is the formula to utilize to calculate the required value of the VC VE, IE, and the VE. Okay, this program, so we have to determine the value of the RB. So we have to see the value of collector voltage, the equivalent to the half of the supply voltage. So this is the B here, C here, E here. The collector voltage BC must be equal to the 10 volt. So this is the half of the supply voltage. So to get a 10 volt, we have to calculate the required RB value. Okay, so in this case, this program given the collector voltage is 10 volt. So BC is equal to 10 volt. The given formula. So firstly, you have to calculate for the RB. To calculate the RB, so firstly you have to calculate the IB. Because of the RB formula is given. So the formula to calculate the RB is the VCC minus VBA by IB. So RB formula can be calculated. RB is equal to VCC minus VBE by the RB. IB. So this is the equation to calculate the RB. So VCC we already know that 20 volt. VBE we already know. VBE is as alpha 0.6 volt for the silicon. So we have to know the IB. We have to calculate the IB. So to know the IB, you also have to know the IC. IC. Because the IC is equal to the beta IB. So beta I already know the 120. So to get the IB, you have to know the IC. If you can calculate the IC, then you can get the IB. So when you got the IB, you will be able to calculate the RB. So therefore, the most important thing you have to calculate is the IC. IC needs to be calculated. Okay, so how we calculate the IC? We find the equation for the IC. IC is a two equation, VE by RE or the VCC minus ICRC. So this is a two equation. So to use the VE by RE, you have to know the VE and RE, but we don't know the VE. So we have to use the VC equal to VCC minus ICRC equation. From that equation, you will be able to find the IC. Okay, firstly we get the equation for the VC equal to VCC minus ICRC. So we transpose this equation. So that from this equation you can substitute. VC is at 20 volt. So VC is at 20 volt. VC is at 10 volt. VC is at 20. IC we don't know. RC value we already know that 3.3 into 10 power 3. So from here you can call the IC. So therefore you get 3.3 into 10 power 3. IC is equal to 20 minus 10 is equal to 10. Then you can call the IC. 10 divided by 3.3 into 10 power 3. So by solving this one, IC value you calculate. So 3.3 into 10 power minus 3 ampere. So we got the IC. After you got the IC, you will get the IB. So IC is equal to beta IB. So then you can call the IC by beta. So IC will be the 3.3 into 10 power minus 3. The beta value is 120. So by solving this one, we got the IB. So IB will be 2.75 into 10 power minus 6 ampere. And then you got the IB, you will be able to calculate the RB. So RB is equal to VCC minus VVE divided by IB. So VCC is at 20 volt, VVE is 0.6, IB is at 2.75 into 10 power minus 6. So by solving this one, there will be 10.05 into 10 power 6 ohm or 10.05 mega ohm. So this is the way we can calculate the RB. So this problem, we want to get the RB value. So the RB formula is VCC minus VBE by IB. Then if you know the IB, you will get the RB. So that we need to find the IB. So that we also find the IB formula. IB is equal to the IC is equal to beta IB. So that from this formula you can get the IB. So you need to calculate the IC. To calculate the IC, we write down the equation for the VC equal to VCC minus ICRC. So from those equation, we substitute the VC value, VCC value, RC value. So you got the IC. So IC, then you got the IB, and then you can get the RB. Okay, so now we will study the transistor amplifier, AC condition of the transistor amplifier. So biasing calculations we calculate for the DC condition. DC condition means that we just supply the DC voltage to your amplifier. So DC voltage amplification means that we just supply the VDC. Then those amplifiers those transistors we calculate how much voltage across the B, voltage across the E, ID, IC, those we calculate. So this is for the DC connection. Now we will consider the AC. AC means that we need to supply the input signal source. So if you only supply the DC biasing voltage, the amplifier is ready for amplification. So to do the real amplification, you have to provide the input signal. And normally we have to provide the input signal to base. And the output signal usually coming out from the collector. So this is for the amplifier. Those amplifiers are emitter, common emitter amplifier. Common emitter amplifier means that this emitter need to be connected to ground. So emitter circuit is included in the both input circuit and the output circuit. So those are the emitter is grounded. It is included in the both input and output circuit. And we apply the AC signal, variance of frequency, variant voltage signal to the base, and we take out the output signal from the collector. Then we can construct the basis amplifier. Now I will draw the equivalent circuit diagram for the common emitter amplifier. This is for the common emitter amplifier. So emitter is RE. So this is the B, C, and the E. So RE is the common. So RE is both included for the input and output. This is the reason to provide the RE is to maintain the stability. Stability means that we need to retain the constant amplification, constant current flow, constant amplification, constant input and the output current. So that to maintain the stabilization, RE has to be utilized. If your RE is a no-go, RE is broken down, in this case your circuit can be unstable. Unstable means that if you are using the radio, you can catch the input signal, output signal, because of the RE which can be if RE is there is a low RE, the circuit can be the instability. So the circuit instability, you need to check the RE. In the meantime, you also need to utilize the coupling capacitor, because this voltage will use the AC signal input. So this DC only this one, DCC, this one DC, but this input applied here with the AC. So those inputs should be the only AC. So this is the input signal coming here, small signal, output signal will use the larger signal. So this is called amplification. Amplifier means the input signal is amplified to the output. Output signal will be much larger than the input. So, but this situation, only the AC signal can be amplified. You can amplify the DC. DC is amplified, so that this DC must not be present across the B. When the DC body is present at the B, so what will happen is that this DC will disrupt the amplification process. So this means that you cannot clearly many disruptions can happen because of the output signal is not proportional to the input signal. In this case, it can undermine the amplification. And therefore, this capacitor C1 and C2 are important to block the undesirable, uncompressible, unexpandable DC voltage. So this is the way we construct. So in the amplifier circuit, in the radio circuit, it contains the many states of the amplifier. So amplifier require the stability. So to maintain the stability, we have to utilize the RE. To maintain the input output signal amplification, we have to use the C1, C2. So AC connection, so the AC characteristic of the three transistor amplifier depend on the voltage gain, input resistance, and the output resistance. So these determine the AC characteristic of the series transistor. The next way is the characteristic of the series amplifier. Common emitter amplifier characteristic. So common emitter amplifier characteristic. Common emitter got the special properties. So this is a common emitter amplifier. They got this special characteristic. The important one is the input signal must not have a no DC component, only AC. Output terminal has a no DC component. Output is a 180 degrees out of phase. So this means the input signal, output signals are totally reversed. So this means the input is this way, output signal will be the this shape. 180 degrees out of phase. So input and output are 180 degrees out of phase. So this is the characteristic of the common emitter amplifier. So in this characteristic of C amplifier, input signal has a no DC component. Only at the base has a both DC and AC. The output terminal has a no DC component. Output signal is 180 degrees out of phase with the input signal. The waveform at the emitter is identical to that at the base. Those are the characteristics of the C amplifier. When we are using the C amplifier, so it contains those are characteristics. Now that we will calculate the voltage gain. So voltage gain, we need to calculate the voltage gain. We need to calculate the emitter resistance. We need to calculate the voltage gain, input resistance. Those things will be calculated for the C amplifier. So we can calculate the voltage gain AV. So AV can be calculated. AV is equal to VO divided by VN. So this is the voltage gain. Similarly, AV also be calculated. Alternative formula is RE by RC by RE. So voltage gain AV is VO by VN in or RC by RE. And also the emitter resistor RE. RE can be calculated. So this is for the this is although you draw this amplifier. So this is for the B, C, and the E. So really this real diagram is that this one the emitter for the little resistance RE. Emitter for the little resistance RE. So this current is the IV. So this is the current will be the IC. IC flow. This is the IE also flowing. So this is for the little resistance RE. So little resistance RE can be also be calculated. IE is equal to 30 millivolt divided by the IC, the milliampere. The way we can calculate for the emitter small RE. This is for the emitter is called the shunt resistance. That resistance can be calculated by that formula. And also there are three formulas for the AV. Voltage gain can be calculated by the output voltage by input voltage, V out by VN, or the RC by RE, or we can also calculate the AV, another formula, RC divided by the RE plus RE. This is for the practical case. Only RC by RE is the approximate formula, but when there is a real more exact formula with the REC divided by RE plus small RE. So this is the way we calculate for the voltage gain for this transistor. The emitters are calculated. Emitters are common emitter amplifier. Okay, so this AV also we calculate. This is for the RC. We do not consider the load resistance. If you load this amplifier, voltage gain will be also be changing. So without loading, we got the low voltage gain and output. So we just put the open voltage, open circuit, so we can measure the input and output voltage for the amplifier. But when you connect it to the load, in this case, the voltage gain will also be changing. So the voltage gain AV will be changing. AV is equal to the RC plus RL divided by RE plus RE. So this is for the emitter common emitter amplifier. AV will be changing. RC plus RL divided by RE plus RE. So once we find the input and output resistance of the input C amplifier, so then we use a C amplifier like this. So this is the RE. So input resistance is this is R1, this is the R2. So we get the input voltage. This is the VN. So this is the RE. So this is the beta. So in this case, we can calculate for the RN. RN means the input resistance RN here. we can calculate Rn is equal to R1 per R2 per beta into Re plus Re. So this is the equation to calculate the Rn. And also the output resistance. So output resistance Ro. Ro is output resistance is equal to Rc. So this is the equation to calculate the input and the output resistance of the C amplifier. Input resistance is R1 per R2 per beta into Re plus Re. Output resistance R0 is the Rc. So this is the way that we calculate. Another thing we also find is emitter bypass capacitor. So this Re, sometimes you can see that one capacitor is bypass at the emitter. The reason to provide the bypass capacitor is to improve the stability, DC stability. So to improve the DC stability, this emitter Re needs to be bypassed with another capacitor. Then we need the emitter bypass capacitor advantage. Adding the emitter bypass capacitor. This circuit you can see that Re can be divided into two components, Re1 and Re2. So part of that Re, for example, Re is 3 ohms, so you can divide it 2 ohm and 1 ohm. So Re2 is connected in parallel with another capacitor, small capacitor Ce. So Ce will be the emitter bypass capacitor. The reason to provide the emitter bypass capacitor is to provide the DC stability. Okay, so this circuit we need to calculate. So we need to calculate that this circuit. This is for the common emitter amplifier. So this is the base, collector, and the emitter. So this circuit arrangement, our R2s are the voltage divider, the biasing resistor, and RCS is the collector resistor RP. Re1, Re2 is already given 380 respectively. Ce is stabilizing capacitor across the emitter, and I is a low C1, C2 will be the coupling capacitor. The reason to provide the C1, C2 is to prevent the DC voltage present. So if the DC voltage is included in the input or output signal, the signal will not be clear. So that we have to eliminate the DC voltage. So we have to eliminate the DC voltage. So the best way to eliminate the DC is providing the C1 and C2. So this is the circuit arrangement for the C amplifier. So in this case, VCC is given as 15 volts. So all the amplifier they are saying collector voltage is only the to 7 volts, so it cannot withstand a full supply voltage. So therefore, that we have to provide the divider resistor. Those divider resistor are RC, R1, R2, Re. Those resistor can reduce the voltage across the collector. So this is the way circuit. So this circuit we need to calculate the DC voltage present at the emitter collector Q1. So this is the we have to calculate all the VV, VE, VC need to be calculated. The gain of the circuit A, we have to be calculated. Input resistance Ri, output resistance Ro to be calculated. And when the CE is disconnected, we also need to calculate the gain and the input resistance. Those we have to be calculated. Okay, so first we need to calculate the DC voltage. So DC voltage at the base emitter and collector, then will be that you have to calculate the VV, VE, and the VC. Those things to be calculated. Okay, firstly we calculate this VV. So VV calculation, the formula will be the VCC into R2 divided by R1 plus R2. So this is the formula to calculate the VV. So in this case, VCC collector voltage is the 15 volt. R2 only given 4.7K. R1 is a 22K. So this is 4.7 divided by 22 plus 4.7. So by solving this one, we got the VC, then we get 2.6 volt. VV is a 2.6 volt. And then we also need to calculate the VE. The formula to calculate the VE is equal to VV minus VDE. So BB will be the 2.6, BE is a 0.6. So then you call the BE will be the 2 volt. And also we also need to calculate for the BC. So BC calculation, we can write down the BC formula. That formula will be the BCC minus IC into RC. So to get the BC, we have to know the IC. So IC, we don't know the IC exactly, so we have to use the formula. So this is the formula to calculate the IC is IC equal to RE. The formula will be the BE by RE. So IC equal to RE is equal to BE by RE. So BE we already know 2 volt. RE we know, so then we can calculate the IC and RE. So we calculate the IC equal to RE. BE value is we substitute. BE value is a 2 volt. RE value. So RE value is a RE1 and RE2 is a combination. So this is a 80 plus 600. So then you go to the IC will be the 3 milliampere. Okay, then you can calculate the BE. So BE will be the BB minus BBE. So BB value is at 2.6 minus BBE. So then we can calculate for the BC. The formula for BC will be the BCC minus IC into RC. So BCC value is 15 volt. IC is 3 into 10 power minus 3. RC value is, we already know the RC 2.7K. 2.7 into 10 power 3. So by solving this one, we got the BC value is at 6.9 volt. And then the BC formula we already calculate the BB, BC, and the BE. So value we calculated. And also we also need to calculate the small RE. The formula to small RE is at 30 millivolt divided by IC. So this is the small RE. I already given the formula 30 millivolt by IC. So IC in a milliampere. So this is 30 millivolt. IC milliampere 3 milliampere. So millivolt by milliampere. So RE will be the 10 ohm. So then we got it. So this is the way that we calculate for the DC connection. DC voltage VB, VE, BC we calculate. Then we calculate small RE. Okay, B. We only need to calculate the gain on the circuit. Gain on the circuit is the voltage gain AB. AB need to be calculated. So the ABs they are the 3 formula. AB formula will be the V0 by Vn, RC by RE, or the RC by RE plus RE, or the RC parallel RL by the RE plus RE. So in this case, this circuit is connected to the load. So connected to the load means that the gain is affected by the load. So that the most appropriate formula to utilize is this formula. AB equal to RC parallel RL by RE plus small RE. So this formula is the most appropriate because this circuit is a non-open circuit. This amplifier connected to the load. So the load impact the gain. The gain influenced by the load can be calculated by this formula. So that we write down this formula for the RC parallel RE by RE plus small RE for AB. So we write down this one. Then we get RC parallel RL divided by RE plus this RE. This RE is a RE1. Then we decide the RE1 because RE2 is a high pass to the capacitor. So only RE1 will be affected. So that one you substitute here. RC is a 2.7K parallel RL. So 4.7K. RE plus small RE1. So RE is a 10. RE1 is a 80. So then substitute. So that will be the 2.7 multiplied 4.7 divided by 2.7 plus 4.7 divided by 90. So by solving this one, we got the thing with this 1715. So divided by this 1.715. K divided by 90. So this is a 1715 divided by 90 ohm. So that will be by solving this one, that will be around 90. So that will be AB is equal to 19. And the C. See, we also need to calculate the input resistance Rn. So Rn we can calculate. The formula we use is R1 parallel R2 parallel beta into Re plus Re1. So this is our formula to calculate the Rn. Okay, so this is Rn, so we can use the equation 1 by Rn is equal to 1 by R1 plus 1 by R2 plus 1 by beta into Re plus Re1. And therefore the Rn is equal to 1 divided by 1 by R1 plus 1 by R2 plus 1 by beta into Re plus Re1. So those things we got. Then we substitute the formula. So 1 divided by 1 by R1. So input resistance R1 is at 22K. So 22K. 22 into 10 power 3. 1 by R2. R2 is a 4.7K. 4.7 into 10 power 3 plus 1 by beta. The beta value is only given as 100. Beta value is given in 100. 100. Re is 10. Re1 is 80. So by solving this one, we can calculate the Ra. Then we use 2710 ohm or 2.71 kilo ohm. So this is the Ra we can calculate. And then number D, we only need to calculate the output resistance R0. So R0 formula, output resistance is that we use this formula. R0 is equal to RC. RC is the resistor. RC value is here we got 2.7. So R0 is equal to RC. So this is 2.7 kilo ohm. And the E. The gain and the output resistance is that CE is disconnected. When the DCC is disconnected, RE value will be the full 600 plus 80. Here is the RE1. We only use the RE1 because of we connect the capacitor. If this capacitor is remote, we can have to utilize the 80 plus 600. So this is the thing here you have to utilize. In the place of the RE1, you have to utilize the full RE. So then you have to use this one. So that this way we have to calculate the RE. This formula will be 1 by R1. 1 by R1 is the unchanged 22 to 10 power 3. 1 by R2 unchanged 4.7 into 10 power 3. The 1 by beta, the beta is remains 100. RE is the unchanged 10. Instead of the RE1, you have to use the RE1 plus RE2 because of the capacitor remote. CE is the remote. When the capacitor CE remote, all the RE1 and RE2 380 is to be utilized. So this similar calculation, but instead place of the only 80, you have to utilize the RE1, RE2. So those days we calculate for the Rn. So the Rn without CE. So the formula we use 1 divided by 1 divided by 22 into 10 power 3 plus 1 divided by 4.7 into 10 power 3. So 1 divided by 100 into 10 plus RE1 is 80, RE2 is 600. So by solving this one, input resistance without capacitor will be 3.7 kilo ohm. So those are the solution for this problem. This means that this is a CE amplifier. CE amplifier, we calculate the DC voltage, VB, VE, and VC. We calculate input resistance, we calculate the output resistance, we calculate the voltage gain for this CE amplifier. Also, we will see that CE amplifier. CE amplifier, the main feature is input and the output signal are 180 degrees out of phase. This means that CE amplifier, input signal voltage is this direction, output signal will be that one. So this is what the main characteristic of the CE amplifier. input signal and the output signals are 180 degrees out of phase. So we don't want the input and output are 180 degrees out of phase. We want the same phase. We want the in phase. In phase means the input signal, output signal here usually the reverse of the inverse of the input signal. So we don't want that one. We want the same in phase. So that to achieve the input and output are in phase, we have to utilize the common collector amplifier. So common collector amplifier is all other characteristics will be the same. So C amplifier, we can there is a load DC voltage. We have to utilize the coupling capacitor to block the DC voltage. So CC we also use it this way. And also there's this amplifier is we can also utilize the impeller capacitor amplifier to retain the stability. We also use this characteristic. Only thing different is for the CC amplifier, input and output are same phase. So this is for the in phase. That will be the CC amplifier. Now I will draw the common collector amplifier. The reason is to provide the in phase input and output voltage. Input and output signal need to be in phase. In this case, we cannot use the C amplifier. Instead, we have to use the CC amplifier. Circuit diagram for the CC amplifier. So you can see the difference. C amplifier, we take out this output at the collector. We take out the output at the collector, and we also put this RT. So this is the C amplifier. So for the CC amplifier, there is a no resistance between the C to the supply, and we take out the output signal from the E to ground. We take out the E to ground output signal, and there is a no resistance between the collector to the VCC. And we give the same input signal. Input signal we usually provide as the base. So this is the input. Being we provide the input. So in this case, you can see the output signal. Output signal will be the interface with the input. So this is for the CC amplifier. C amplifier output is 180 degree out of phase, but CC amplifier output will be the interface with the input. So there is a no resistance between the C to VCC, and we take out the output signal from the E terminal. So this is for the configuration of the CC amplifier circuit. So all other circuits characteristics are similar to the CE and the CC, but the only the major difference is output signal will be the interface with the input signal. So we use the same formula. That will be the VBA square to VCC into R2 divided by R1 plus R2. We also use the VE. V is the VV minus VBE. And IE equal to IC is equal to VE by RE. So we use the same formula. And also there's VC is equal to VCC. So those are in the CC amplifier. They are the formula. Both formulas are similar to the C amplifier formula. Okay, both formulas are similar. The only thing different will be the voltage gain. So voltage gain for the C amplifier is that we utilize RC per RL divided by RE plus RE1. But for the CC amplifier, voltage gain is ever 1. And the input resistance is that we calculate the C amplifier, R in square to R1 per R2 per, and there's beta into RE plus RE1. So this is for the input resistance. But for the CC amplifier, input resistance is another formula. Input resistance will be the R1 per R2 per beta into RE, small RE plus capital RE and per RL. So this is for the formula for the CC amplifier. CC amplifier, VV calculation, VE calculation, RE calculation, IC calculations are the same. VC is here equal to VCC. But the C amplifier is a VCC minus ICRC. but CC amplifier, VCC is equal to VC. And voltage gain ever 1, input resistance is R1 per R2 per beta into RE plus capital RE per RL. So this is for formula for this common amplifier and common volatile amplifier. Small RE. Small RE is the same formula, 30 millivolt divided by IC. So this is for the small RE formula. Also, we can also calculate output resistance. If we want R in this formula, R is ever equal to RE. This is for the CC amplifier. Okay, so firstly you need to calculate for the RE. This is for the packet given. This is the CC amplifier configuration. You can discriminate. CC amplifier does not have the resistor between volatile to the VCC. So this is a CC amplifier. And output is taken out from the emitter. But CE amplifier output is taken out from the volatile. There is a resistor between the volatile to VCC. So this circuit configuration is a CC amplifier. So this CC amplifier, we need to calculate the RE, we need to calculate the gain on the circuit, input resistance, and the output resistance. They are required to be calculated. Okay, firstly we calculate for the RE. RE formula is given the 30 millivolt divided by IC. So this is the equation. 30 millivolt divided by IC to be calculated. Okay, so IC value is already given here. The IC value is 7.7 milliampere. So IC is given. So how to calculate the IC? So firstly you need to calculate that IC is equal to VE. IE is equal to VE by RE. So this is the formula. IC formula here. IC is equal to IE is equal to VE by RE. So VE value is given. So we need to calculate the VE. So how to calculate the VE? VE is also given a formula here. VE is equal to VB minus VBE. VB minus VBE. In this case, we want to calculate RE, so you need to know the IC. So to calculate the IC, I is a VE by RE, so you need to calculate the VE. VE is a VB minus VBE. So have to be calculated. Okay, so VB, the VB value, how to calculate the VB? VB is given as 8.3 volt. So VB, we calculate. We also need to calculate VB. So VB formula is VCC R2 divided by R1 plus R2. So this is a VB is equal to VCC R2 divided by R1 plus R2. So those are the formula. So we want the RE. So we need to know the IC. So to get the IC, we need to know the VE and RE. So VB. So to get the VE, you need to know the VB. So firstly, you have to start on the VB. VB formula is a VCC R2 divided by R1 plus R2. So we already know the VCC 15 volt. R1, R2 are also, we already know the 22 and 27K. And therefore that you can calculate the VB. So firstly, we calculate the VB part. VB is equal to VCC is at 15 volt. R2 value is at 27. R1 plus R2 is 22 plus 27. Then you call the VB will be there 8.3 volt. And then the VE you can calculate. VB minus VBE. So 8.3 minus VBE is 0.6. So then you call the voltage will be the 7.7 volt. And then you also need to calculate the IE and the IC. IE equal to IC, this is the VE by RE. So VE by RE is VE is equal to the 7.7. RE is, we calculate RE is 1 kilo ohm. 1 kilo ohm. So then we get 7.7 milliampere. So IE and IC we calculate it. And then so this is the way we calculate the IE. And then you can now start calculate the RE. RE is 30 millivolt by IC. So this is 30 millivolt. IC is 7.7 milliampere. Then you call the RE. RE value will be the so here we calculate RE will be 3.9 ohm. So this is the way now we calculate for the RE. So first answer we got it. And the B, the gain on the circuit. The gain on the circuit is that this is a CC amplifier. The gain is at 1. So the gain wave is at 1. Gain is equal to AV is equal to 1. And the C, we also need to calculate the input resistance. Input resistance Rn. Rn is formula with the R1 parallel R2 parallel beta into Re plus Re parallel Rl. So those things are the formula. Okay, so firstly you have to calculate the Re parallel Rl. So we write down this formula here. Rn is equal to R1 parallel R2 parallel beta Re plus Re parallel Rl. So this is the equation to calculate. So now we write down the equation here, Rn. So 1 divided by 1 by R1 plus 1 by R2 plus, so this is a 1 divided by, so 1 divided by beta Re plus Re parallel Rl means Re divided by Re plus Rl. So this is the equation we solve. Okay, so this is how we substitute in the formula. So that we already know the all values, so we just substitute in formula. 1 divided by 1 by R1. 1 by R1 is 22K. 22 into 10 power 3. 1 by R2. So 27K. 27 into 10 power 3. Plus 1 divided by beta. The beta value is already given. So this problem, beta is the 200. So here we got the beta is a 200. Beta 200 we substitute. So 1 by 200. Small Re we already calculated. Small Re wave is 3.9 plus Re into Rl. So Re value is 1 kilo ohm. 1 into 10 power 3. Rl wave is 470. Divided by 1 into 10 power 3 plus 470. So by solving this one, we can calculate the RC. RC wave is 10.2 kilo ohm. So this is for the RC. Rn we calculate. And finally, the output resistance RO. So output resistance R0 is equal to Re. So Re is that we already know that 1 kilo ohm. So Re is R0, and this is for the small Re. This is not capital Re, just small Re. The small Re is R0 is equal to small Re, so 3.9 ohm. Output resistance R0 is equal to small Re, so 3.9 ohm. So this is for the solution for the CC amplifier. So move for the amplifier solution. The next topic will be the application. So C amplifier is a real utilized for the amplification. Because of the amplifier is we have to provide the gain. So you see here this CC amplifier, gain is a unity. Unity means input and output signal are the same. Input is 1 volt, output also 1 volt. So why we use this amplifier? The only reason we use this amplifier is for the buffer. Buffer means in the sometime we don't want the unwanted charge, voltage charge or unstable signal. So we want to block any voltage charge or unstable signal. So in this way we have to utilize the CC amplifier. Especially the buffer things in the electrical system, we use the buffer when the voltage charge in the input can damage the output equipment. So in this case, we don't want the unwanted signal need to be blocked. In this case, we use the CC amplifier as a buffer. So buffer, we use the autocoupler. Autocoupler means instead of using the electrical, we use the light, the autocoupler. The autocoupler is amplifier for the buffer. And similarly, we use the CC amplifier as a buffer. So the CC amplifier got the amplification, but CC amplifier we utilize as a buffer. So this is a CC, because CC amplifier is a gain is a 1. Okay, the next one will be the common base amplifier, CV amplifier. Common base CV amplifier. So we did a circuit. I will give you the circuit diagram for the CV amplifier. So CV amplifier is, we call it a CE amplifier and the CC amplifier. We give the input signal to the base. But for a CV amplifier, we provide the input signal to emitter. We provide the input signal to emitter, and output is taken out from the collector. So this is a CV amplifier. So CV amplifier does not have any current gain. It only has a voltage gain. So this is the characteristic of the CV amplifier. Compare the three amplifier, CE, CV, and the CC. We made the comparison. So then we made the comparison in terms of the input resistance, output resistance, phase shift, voltage gain, current gain, and the power gain. Those characteristics we compared for the CE, CC, and the CV amplifier. Special characteristics, we compare the CE, CC, and the CV amplifier. So commutaration CE is the input resistance medium, output resistance within the medium. So this is minus RC. Phase shift is 180 degree. Voltage gain high. Voltage gain AV is high. Current gain within the medium, and power gain is high. A special feature we have to utilize the IE stabilizer. IE is utilized as a stabilizer. So we utilize for the amplification. So CV amplifiers are input resistance is high, output resistance is low, minus RE, phase shift 0, voltage gain unity, current gain high, power gain high, and we use as a buffer. Because AV is equal to 1. For the CV amplifier, so input resistance is low, output resistance is minus RC. This is the medium. Phase shift 0 degree, voltage gain medium, current gain unity, power gain AV is a medium. So there is no AI and only AV. So those is a special feature of the CV and the CC amplifier. Okay, so for the G12 analog portion, today I teach you as a buffer. So the CE amplifier got the amplification, but CC amplifier we utilize as a buffer. So this is a CC, because a CC amplifier is a gain is a 1. Okay, the next one we did as a common base amplifier, CV amplifier. Common base CV amplifier. So we did a circuit. I will give you the circuit diagram for the CV amplifier. So CV amplifier is, we call it a CE amplifier and the CC amplifier. We give the input signal to the base. But for a CV amplifier, we provide the input signal to emitter. We provide the input signal to emitter, and output is taken out from the collector. So this is a CV amplifier. So CV amplifier does not have any current gain. It only has a voltage gain. So this is the characteristic of the CV amplifier. Compare the three amplifier, CE, CV, and the CC. We made the comparison. So then we made the comparison in terms of the input resistance, output resistance, phase shift, voltage gain, current gain, and the power gain. Those characteristics we compare for the CE, CC, and the CV amplifier. Special characteristics, we compare the CE, CC, and the CV amplifier. So commutaration CE is the input resistance medium, output resistance within the medium. So this is minus RC. Phase shift is 180 degree. Voltage gain high. Voltage gain AV is high. Current gain within the medium, and power gain is high. A special feature we have to utilize the IE stabilizer. IE is utilized as a stabilizer. So we utilize for the amplification. So CV amplifiers are input resistance is high, output resistance is low, minus RE, phase shift 0, voltage gain unity, current gain high, power gain high, and we use as a buffer. Because AV is equal to 1. For the CV amplifier, So input resistance is low, output resistance is minus RC. This is the medium. Phase is 0 degree, voltage gain medium, current gain unity, power gain ABS and medium. So there is a no AI and only AB. So those is a special feature of the TCB and the CC amplifier. Okay, so for this the G12 analog portion. Today I teach you the amplifier biasing circuit, amplifier configuration. So amplifier configuration, principle of the amplification, amplifier characteristic configuration. So transistor biasing circuit to determine the DC characteristic, and amplifier configuration for the AC characteristic. So in this case, there are the three configuration of the amplifier: CE, CC, and a CV amplifier characteristic. So those are the basic principle of the amplifier. And later times, I will give you the multi-stage amplifier and the feedback, and also the PFS transistor, better characteristic. Those are the bipolar junction transistor, BJT transistor. PFS transistor are better characteristic and better quality. Those will be given, and then I will give you the power output state driver and power supply. Those things I will continue to give them over the next 8 weeks. And then I also do this digital portion.